Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Angles, Vertical, Complementary, and Supplementary. Alright, let's start talking about some vocabulary that you're going to see all throughout these guided notes, starting with this interesting looking symbol. This is the symbol for an angle, which is quite convenient because it actually looks like an angle. Two rays coming together at a vertex, that's what angles look like. So this is the symbol used in geometry for an angle. Now, if you ever see a little M to the left of an angle symbol, that is going to represent the actual angle measure for that angle, which we're going to measure our angles in degrees. Now, here's a super important word that you're going to want to underline and learn this word. You're going to hear this a lot, not just in this packet of guided notes, but in the next one as well, and that is the word congruent. It means having the exact same measure. So that is definitely worth underlining, highlighting, putting stars next to or whatever. That is a word you're going to hear a lot of throughout these guided notes and the next. And the symbol for congruent is an equal sign with a little wave on top. So if you ever see angle 1 and this symbol, angle 3, that means angle 1 is congruent to angle 3, which means they have the same measure. Now, if that confuses you, when we say angle 1, we do not mean 1 degree. Angle 1 means the first angle that's labeled with the 1. Angle 2 would be the second angle, labeled with the 2. Angle 3 would be the third angle, labeled with the 3. So it's a numbering system to help you to distinguish what angle is what from a drawing that has multiple angles. Now, before we go any further and get into the new vocabulary that we're going to learn at here at the 7th grade level and pre-algebra level, let's talk about stuff from previous years of math. Categories of angles: acute angles, obtuse angles, right angles, and straight angles. Now, you probably remember from using protractors in previous years of math, maybe back in elementary school, that a right angle meets exactly here at 90 degrees. A straight angle, you might not have heard of that word before, maybe you have, maybe you haven't, measures 180 degrees. And then any angle that is less than 90 is called acute, and any angle that is greater than 90 is called obtuse. So those are just general categories for angles. I would like to point out straight lines make straight angles, always equal to 180 degrees. And anytime you see a little square in the corner of an angle, I guarantee you that is a 90-degree angle, which we call a right angle. That's something to keep in mind as we move forward. All right. Let's get to the actual new vocabulary for these guided notes. Vertical angles. This is the first big one. There's going to be two more that are really important. Vertical angles are a pair of angles that are opposite of each other when two lines intersect. And let me show you what I mean by this. I got a couple of different examples here for you. This angle here over on the left, which happens to measure 40 degrees, that angle is opposite of the other angle that opens up to the right, which also happens to measure 40 degrees. So check this out. Vertical angles are congruent. Feel free to underline that on your page. And when I say opposite of each other, I don't mean next to each other. I don't mean adjacent. So I'm not talking about like, these two angles here that are actually adjacent to each other. Those are not vertical angles. So we're talking about angles that are going in the complete opposite directions of each other. So on this drawing, there's actually another pair. If I can move these red angles out of the way. The one that opens up and the one that opens down, they are also a pair of vertical angles, and they would also be congruent. They would actually measure 140 degrees. How do I know it's 140? You'll see why when I get down to the one called supplementary angles, coming up later. Looking over here on the right side, here's another set of examples here. We have two angles going in complete opposite directions of each other. Here we have this one moving or opening up to the bottom left. Here we have this one opening up to the top right. You can see they're both the same type of angle. They are congruent. They're both measuring 102 degrees. And I could show you the other pair here on the same drawing. The angle that opens up to the top left and the angle that opens up to the bottom right. They are complete opposite angles of each other. They happen to both be equal to 78 degrees. They are congruent. They are a pair of vertical angles. So vertical angles doesn't actually mean vertical up and down. It just means angles that are opposite of each other formed by two lines that happen to intersect. Now, taking a look at a sample problem that you might see on a quiz. Here we have a drawing, and we have two different angles measured, and we have the one here called x. Problem number 1, find the value of x. All right, so let's get our pencils in our hand. Is x equal to 118 or is it equal to 62? Well, based on what we learned from vertical angles, x degrees opens up here to the left, and it just so happens that the angle that is a vertical angle with it, meaning opposite angles of each other, is the one that is 62 degrees. So they are congruent. They are the same measure. So go ahead and write this down. X is equal to 62 degrees. Now, vertical angles are not the only type of new vocabulary we want to talk about today. We also want to talk about complementary angles and supplementary angles. So what are complementary angles? Complementary angles are two angles, so a pair of angles, whose measures sum, which means adding, their sum is 90 degrees. So, for example, you see this pair of angles over here, the 63 degree angle, the 27 degree angle. Go ahead, pencils in your hand, write this down. If I would take 63 plus 27, what do they happen to equal? They happen to equal, boom, 90 degrees. So that proves to you, based on this definition, that we have a pair here of complementary angles because their sum is equal to 90. What about this drawing over here? I have a straight line, a straight angle, and from it I have two other angles. Notice the square. The square means 90 degrees. And it just so happens that if you have a 90 degree angle sitting nice and flat here on a straight angle, then you could also conclude that this angle to the right would also be 90 degrees. Well, on this unique drawing, there are two angles that together would form that 90 degree angle, the 40 degree angle and the 50 degree angle. And lo and behold, if I take 40 plus 50, what do I get? Boom, 90 degrees. So that means this blue angle here and this red angle here, they are a pair of complementary angles. All right, what are supplementary angles? They are two angles whose measure sum is 180 degrees. So, for example, here we have a 63 degree angle and a 117 degree angle. Go ahead and write this down on your paper. 63 plus 117, what does it equal? It happens to equal 180 degrees. So therefore, this is a pair, by definition, a pair of supplementary angles. And then we have this pair over here. We have a 130 degree angle and we have a 50 degree angle. And look, they together form a straight angle, literally a straight line. And what do we know about a straight angle? Well, we learned higher up on your page, if I can go back to it real quick here for you, a straight angle measures 180 degrees. So back to where I was, since the 130 and the 50 degree, the blue and the red, they together form a straight angle, that proves there are going to be a pair of supplementary angles because, again, write this down, 130 plus 50 makes 180 degrees. And I knew it was going to make 180 degrees because the measure of a straight angle is 180 degrees. All right, so let's take what we just learned and do two problems together where the directions say find the value of x. All right, problem number 2. You see that we have this angle called x. I'm going to make it a red angle here. And I have the 62 degree angle that it's right next to. Notice those two angles together form the square. What do we know about the square? The square means a 90 degree angle. So this means that the x degrees could be added to the 62 degrees and be set equal to 90. Again, how do I know it can be set equal to 90? Because of the square. If those two adjacent angles together form the 90 degree angle, then their measures would add together to equal 90. Now, how could I solve for x? Well, inverse of adding by 62 is subtracting by 62, and that's going to give me 28 degrees. Now, would I have to show my work like an equation? Not necessarily. Here's what I could have done. I could have just said 90 minus 62 is 28. So I'm not going to force you to show your work as an equation for a simple problem like this, but you could. So it's kind of personal preference here. What about problem number 3? Here, once again, we have an angle called x, and we have an angle 34 degrees. Now, this time, there is no square, so there is no 90 degree angle, But these two adjacent angles, the blue and the red, together form a straight angle. Well, what do we know about straight angles? We know they measure 180 degrees. So pencils in your hand. That means we could say that 34 plus x could be equal to the 180 degrees. That's what this straight angle is, 180 degrees. So how do I solve for x? Well, once again, inverse of adding is subtracting. That's going to give me 146 degrees. And like I said last time, you don't necessarily have to show your work as an equation. If you just did 180 minus 34, giving you 146, I have no problem with that. It's up to you whether you want to show it as an equation or not. All right. You might have heard me say this word already several times, and that is the word adjacent. Adjacent is a word you actually hear in regular real life English that happens to mean next to each other. And adjacent, in terms of geometry, will share a common side. So angle 1 and angle 2, they actually share a common side in between, and they're right next to each other. So by definition, that's what we call adjacent angles. Now, on the previous drawings we had on the first page, there were many pairs of adjacent angles, especially problem number 2 and problem number 3. Here you can see on problem number 3, we had two angles next to each other with a common side in between, so they were a pair of adjacent angles. Here on problem number 2, we had two angles side by side, again with this ray in between, so they are a pair of adjacent angles. All right, so just letting you know what adjacent means. All right, let's do some actual practice problems. And this first one I'll kind of do with you a little bit. If you already feel like you're ready to do 4, 5, and 6 on your own, then go right ahead and hit pause and try them on your own, and then hit play when you're ready to see how you did. If you don't quite feel 100% ready, let me go ahead and lead you through 4, 5, and 6, along with you. So here we go. Problem number 4. We're looking for a pair of vertical angles. Now, what do we know about vertical angles? If you don't remember, you can look back on the first page. They are angles opposite of each other formed by two intersecting lines. Well, here we definitely have two intersecting lines. Angles that are opposite of each other. Well, that could be angle 1 and angle 2. They are a pair of vertical angles, but that isn't the only one you could have picked. There is another pair, and that would be, oh, sorry, I thought I had it here. Oh, there it is. Angle 3 and angle 4, they are also opposite angles of each other. So that could have been the other choice you could have chosen for the answer here to problem number 1. Now, it didn't say you had to write down both pairs. It only said a pair, so it's up to you which pair you want to write down. Either one will work. All right, what about problem number 5? Identifying a pair of supplementary angles. Now, what do we know about supplementary angles? They're a pair of angles whose measures would add together to give you 180 degrees. How can we identify them? Well, here's the trick. Look for a pair of angles that together would form a straight angle. So that could actually be angle 1 and angle 3, or I could have said angle 1 and angle 4 together would form a straight angle. And actually, I could do even other pairs here. I could have said angle 3 and angle 2. They form a straight angle. And finally, I could have said angle 2 and angle 4. Now, I don't care which one you pick. You don't have to write all possible 4 pairs down. Whichever one you want is fine with me. All right? But bottom line, you're looking for two angles that are right next to each other that together form a straight angle, because straight angles are 180, and it just so happens supplementary angles are two angles that add to equal 180 degrees. All right, problem number 6. Identify a pair of adjacent angles. Well, wait a minute. Weren't my supplementary angles also right next to each other, and therefore by definition adjacent to each other? Well, yes, they were. So whatever answer you wrote for number 5, you can write the exact same answer for problem number 6. Or you can be creative and choose a different pair of angles that are right next to each other. So these are not vertical angles that are opposite of each other. These are angles that are right next to each other, sharing a common ray in between those two angles. All right. Now that I went ahead and led you through problems 4, 5, and 6, I would like for you to try problems 7, 8, and 9 on your own. And before I tell you to hit pause and try this, don't forget the little m's mean the measure of the angles. So keep that in mind when you get to problem number 8. All right, hit pause on the video, try 7, 8, and 9 on your own, and then hit play when you're ready to see how you did. All right, did you already try 7, 8, and 9 on your own? If not, you better hit pause now. You got to try some on your own. That's part of learning when it comes to math especially. All right, number 7. We're looking for a pair of vertical angles. Now, you notice instead of having 2 lines intersecting, here we had 3. So that does make it a little bit trickier, but there are 3 different pairs of vertical angles that you could have chosen. You could have chosen angle 1 and angle 4. You now see, now that I've made them red for you, that they definitely are opposite angles of each other. So that's one possible pair. Another possible pair could be angle 2 and angle 5. They are opposite angles of each other. And there's actually one more pair, and I didn't actually make this a different color, but these are the ones that are right angles. Angle 3 and angle 6 are both opposite angles of each other. Angle 3 kind of opens up to the right. Angle 6 opens up to the left. Opposite angles, both equal to 90 degrees. They are the third possible pair you could have chosen of vertical angles. All right, problem number 8. The measure of angle 1 and the measure of angle 2 and the measure of angle 3, if I add them together, what will they equal? Well, let's think about this. Here we have angle 1. Here we have angle 2, and then we have angle 3. Those 3 angles would together form, boom, a straight angle. What do we know about the measure of a straight angle? We know it is 180 degrees. So since those 3 angles together formed a straight angle, we know the 3 angles' measures would add together to equal 180 degrees. All right, finally, problem number 9. Identifying a pair of complementary angles. Now, a lot of kids will try to say angles 3 and 6, but then that means they don't understand what complementary actually means. Complementary doesn't mean the angle itself equals 90. It means it's 2 angles that when you add them together, it equals 90. So here's how you do this. If angle 3 is 90 degrees, then if you slide that right angle symbol, that square, along this straight line, you would see that angles 1 and 2 would also together form a right angle. So that means angles 1 and 2 are a pair of complementary angles, but they're not the only pair. Again, since angle 3 and angle 6 are both right angles, I could slide the right angle symbol along this straight line, and you would see that angle 5 and angle 4 would together form that 90-degree angle. And so therefore, they're the other pair of complementary angles. So, little trick I want you to remember, and I did mention this on the first page. If you see a right angle symbol, you can, and it happens to be on a straight line, you could therefore conclude that you would also have a right angle right next to it. And that could be slid either way, since we had straight lines this way and a straight line going that way. That's a trick that's going to be very helpful for the future. All right, finally, last 2 problems on this page, problem 10, problem 11. I want you to try them both on your own. Again, feel free to flip back to the first page to refresh your memory on what the vocabulary words are. Hit pause on the video, try 10, 11 on your own, and then hit play when you're ready to see how you did. All right, did you already try 10 and 11? If not, you got to try them now on your own. Problem number 10. Angle A, angle B are a pair of what type of angles? Well, it just so happens that if you take 68 plus 22, you would get 90. What do we know about angles that are 2 angles that together would add to equal 90? We know they are called complementary angles. And here's how I explain how I know. Their sum, meaning adding them together, is equal to 90 degrees. Well, what about problem number 11? Angle C, angle D. What type of pair of angles are they? Well, if you take 68 plus 112, you get 180 degrees. What do we call pairs of angles whose sum is 180 degrees? We call them supplementary angles. And again, the explanation would just be to say that if you add them together, their sum is 180 degrees. All right, there is a third page of the guided notes. I'm going to make that a separate video. So whenever you're ready for that next video, feel free to watch it. But I'm going to go ahead and finish this one. Thank you for watching this one for pages 1 and 2 of vertical, complementary, and supplementary angles. We'll see you next time.